Right now, beneath 600 meters of limestone and ocean sediment off the coast of Mexico, there is a scar. It is 180 kilometers wide. It punches 30 kilometers into the Earth's crust. Scientists call it the Chicxulub crater, and it is the most violent crime scene in the history of this planet. Nobody found it until 1978. Geophysicist named Glenn Penfield was running a gravity survey for a Mexican oil company, Pemex, when he noticed something strange in the data. A perfect arc, too geometric to be natural, too massive to be anything but catastrophic. He had just found the murder weapon. This is the story of the last day that the dinosaurs ever saw, minute by minute. This is a dark chapter. To understand what was lost, you first need to understand what existed. 66 million years ago, late Cretaceous period. The Earth looks nothing like the planet. You know, there are no polar ice caps. Global average temperatures run 8 to 10 degrees warmer than today. Sea levels are so high that North America is split in two by an inland sea. Scientists call it the Western Interior Seaway. It stretches from the Gulf of Mexico all the way to the Arctic Ocean. Non-avian dinosaurs have ruled this planet for 165 million years. To put that in perspective, modern humans have existed for roughly 300,000 years. The dinosaurs had us beat by a factor of 500. Titanosaur sauropods, the largest land animals Earth has ever produced, graze in herds. Triceratops patrol lowland floodplains. And in the forests of what will one day become Hell Creek, Montana, Tyrannosaurus rex rules as the apex predator of an entire continent. But something is already wrong. Deep beneath India, a geological catastrophe is already underway. The Deccan Traps, one of the largest volcanic provinces in Earth's history, have been erupting for thousands of years. Lava flows have blanketed over 500,000 square kilometers. Sulfur dioxide and carbon dioxide are slowly destabilizing the global climate. Some fossil records suggest certain dinosaur lineages were already in ecological stress. The planet is already wounded. It just doesn't know the killing blow is coming. In the asteroid belt between Mars and Jupiter, or possibly dislodged from the URT cloud by a gravitational nudge, a rock is moving. It has been moving toward this moment for millions of years. Its diameter, approximately 10 to 12 kilometers. Its composition, chondritic rock, rich in iridium, an element rare on Earth but common in asteroids. This iridium will later become the forensic fingerprint that allows scientists to find this exact moment, preserved in a thin layer of clay, in rock strata all over the world. Its speed, roughly 20 kilometers per second, that is, 72,000 kilometers per hour. At that velocity, it could travel from London to New York in under 4 minutes. The dinosaurs have no warning system, no satellites, no astronomers. When it appears in the sky, it just looks like a very bright star, one that is getting bigger every single second. Before we go further, here is a question that has divided scientists and philosophers for decades. The Chicxulub impact killed 75% of all species on Earth, but it also cleared the path for mammals, and eventually for us. Was this asteroid the greatest catastrophe in the history of life, for the most necessary event in human history? Drop your analysis in the comments. I want to know what you think. The moment of atmospheric entry would have been visible across the entire Western Hemisphere. The superheated plasma sheath surrounding the asteroid burned brighter than the sun, and a dinosaur that looked up would have been blinded instantly. The object entered at an angle of approximately 60 degrees, a trajectory that at the University of Texas later determined was close to the worst possible angle. A shallow or steep entry would have released more energy upward into space. At 60 degrees, the energy was driven deep into the crust, horizontally across the surface. It struck shallow coastal water near what is now the Yucatan Peninsula of Mexico. The moment of contact lasted a fraction of a second. In that fraction of a second, the asteroid ceased to exist. It didn't just hit the ground, it vaporized. It transferred its entire kinetic energy, estimated at 100 teratones of directly into the Earth's crust in milliseconds. 100 teraton, that is 1 billion times more powerful than the atomic bomb dropped on Hiroshima. Let that land. The crater that formed was 180 kilometers wide and 30 kilometers deep. The bedrock behaved like liquid material from deep inside the earth, rebounded upward in seconds, forming a temporary mountain taller than Everest, which then collapsed back down under its own weight within minutes. The thermal pulse that radiated outward from ground zero incinerated everything within 1,500 kilometers in milliseconds: trees, animals, water, gone. Before any of them could register pain, the seismic wave generated by the impact triggered earthquakes, estimated at magnitude 11, possibly 4. For context, the most powerful earthquake ever recorded by modern instruments was the 1960 Valdivia earthquake in Chile, which measured magnitude 9.5. The Chicxulub quake was orders of magnitude beyond that. It made the entire Earth ring like a bell. Those seismic waves traveled to the opposite side of the planet, and when they converged, they triggered new volcanic eruptions along existing fault lines. The already active Deccan traps in India surged. The planet was attacking itself from within. The asteroid impact was not one event. It was a chain of events, each one more lethal than the last. Because the asteroid struck shallow water, it completely displaced the ocean. The displacement generated with initial wave heights calculated at 1.5 kilometers, tall enough to submerge the Empire State Building twice over. This wave moved at the speed of a commercial jet. It annihilated every coastal ecosystem within hours. We know this, not just from computer models. We know it from a fossil site. In 2019, paleontologist Robert De Palma and his team at the University of Kansas published findings from a site in North Dakota called Tanis. Tanis sits 3,000 kilometers from the impact zone, but in its geological record, freshwater and marine fossils are violently mixed. Fish fossils were found with tiny glass spheres called tektites embedded in their gill arches. These tektites were formed when impact debris was blasted into suborbital space, cooled into glass droplets, and rained back down through the atmosphere. The fish at Tanis died gasping, with glass falling into the water around them within the first hour of impact. Tanis is not just a fossil site. It is a photograph, a direct snapshot of that exact day, preserved in stone. But the debris field that created those tektites at Tanis was just the beginning of the second wave of destruction. Billions of tons of superheated rock and dust had been blasted out of the crater and into suborbital space. Gravity brought it all back down. Over the next few hours, this debris re-entered the atmosphere. The friction of re-entry caused the upper sky to glow, not like a sunset, like an oven. Atmospheric temperatures at altitude reached 300 to 400 degrees Celsius. That thermal radiation was intense enough to ignite dry forest on the ground below, without any flame reaching the surface. The trees simply caught fire. A global wildfire had begun. Any dinosaur that had survived the initial blast, the earthquake, and the tsunami now faced a planet on fire. The air itself was too hot to breathe. Lungfuls of superheated air would have scarred the respiratory tissue from the inside. There was nowhere to run. Survival in those first hours came down to a single factor. Were you underground or underwater? Here is your dark chapter dilemma for this video. The asteroid that ended the dinosaurs struck a region rich in sulfur-bearing rock. If it had struck almost anywhere else on Earth, open ocean, granite bedrock, the sulfur aerosol injection would have been far less severe. The impact winter might have lasted months instead of years. More species might have survived. But if more species survived, mammals might never have dominated. They might not exist. So here is the question. If you had the ability to redirect the asteroid to a less catastrophic target zone, knowing it would likely prevent human evolution, would you do it? Comment below. This one has no clean answer. The fires were devastating, but they burned out. What came next was worse, far worse, and it lasted years. The rock that struck the Yucatan Peninsula had an especially cruel geological fate. The local bedrock was composed largely of anhydrite and gypsum, Sulfur-rich minerals. When the asteroid vaporized these rocks, it injected an estimated 325 billion tons of sulfur aerosols directly into the stratosphere. Combined with the soot from the global wildfires, this created an opaque barrier across the entire sky. Sunlight could not reach the surface of the Earth. Photosynthesis stopped. This is the moment scientists call the impact winter, and it is, arguably, the actual extinction mechanism, not the explosion, not the fire, not the tsunami. Climate models, published by researchers at the Potsdam Institute for Climate Impact. Research suggests global temperatures dropped by an average of 25 degrees Celsius within weeks. Some regional estimates are even more severe. The warm, tropical world of the Cretaceous had become a dark, frozen wasteland. In less than a month, the food web didn't collapse gradually. It collapsed from the bottom up, almost immediately. No sunlight, no photosynthesis. Plants and phytoplankton died first. Without vegetation, the large herbivores, Triceratops, Edmontosaurs, and Chalosaurs began to starve. An adult Triceratops needed hundreds of kilograms of plant matter every single day just to maintain its body mass. That food simply ceased to exist. As herbivore populations crashed, the large carnivores initially feasted on the dying and the dead. But once those carcasses rotted away, Tyrannosaurus rex, the apex predator of the Western Hemisphere, had nothing left to eat. The oceans suffered a parallel catastrophe. The sulfur dioxide and carbon dioxide injected into the atmosphere dissolved into seawater. As carbonic and sulfuric acid, ocean pH dropped sharply. The calcified shells of marine plankton, the base of the entire marine food web, dissolved. As plankton died, small fish died. As fish died, the great marine reptiles, Moses plesiosaurs, vanished into the deep for the last time. Approximately 75% of all species on Earth went extinct, many within months. The Cretaceous, Paleogene extinction. The KPG event was not a single catastrophe. It was a cascading, self-reinforcing system failure. Each disaster triggered the next. The asteroid pulled the first domino, and then the world destroyed itself. When the sky finally cleared months, possibly years later, what remained was a quiet planet. No roar of a T-Rex. No thunderous footsteps of sauropods. No herds. Silence, broken only by wind, but not complete silence. Survival at the KPG boundary came down to three factors: body size, dietary flexibility, and access to shelter. The survivors who checked all three boxes are the reason any of us exist today. Mammals. The mammals of the late Cretaceous were small, mouse-sized too, rat-sized mostly. They lived underground, in burrows. On the night of the impact, when the sky was raining superheated glass and the atmosphere was on fire, those burrows functioned as blast shelters. During the impact winter, they provided insulation against lethal cold. And critically, these mammals were omnivores. They could eat dead insects, seeds, roots, fungal matter. In a world where the normal food chain had collapsed, the ability to eat almost anything was the ultimate survival advantage. Within 10 million years of the extinction event, mammals had diversified from small burrowing generalists into whales, bats, horses, elephants, and eventually U.S. crocodilians also survived. Their semi-aquatic lifestyle buffered them against temperature extremes and fire. And a crocodile's metabolism is so slow, it can survive without food for over a year. That metabolic efficiency made them nearly impossible to starve out. And then there were the birds. Here is the thing that most people don't know. Non-avian dinosaurs did not fully go extinct. A specific lineage of small, feathered theropod dinosaurs, relatives of Velociraptor, survived. They had beaks capable of cracking open seeds. They were small enough to shelter in crevices and tree hollows. Even seeds can survive in soil for years without light or warmth. These feathered survivors are the direct ancestors of every bird alive today. That pigeon on your window ledge, that crow watching you from a telephone wire. They are, technically, living dinosaurs, the last unbroken lineage from the age of giants. Birds are the only dinosaurs left on Earth. Tyrannosaurus rex is gone, but its evolutionary descendants are outside your window right now. Before we close, consider this. The asteroid that ended the Cretaceous did not have to hit where it hit. Researchers at the University of Tohoku in Japan ran trajectory simulations and found that if the asteroid had arrived approximately 30 seconds earlier or 30 seconds later in its orbital path, it would have struck the deep ocean instead. Deep ocean water absorbs impact energy dramatically. The sulfur-rich Yucatan bedrock, the source of the aerosol injection, would never have been vaporized. 30 seconds. In a universe measured in billions of years, the difference between the existence of humanity and its permanent impossibility was 30 seconds. The same event that wiped out 75% of life on this planet cleared the ecological space that mammals needed to evolve. Without the KPG extinction, the small, burrowing ancestors of every primate on Earth would likely have remained small, burrowing animals, permanently suppressed by a world still dominated by dinosaurs. You exist because of the worst day in the history of life on Earth. That is a dark chapter worth knowing. Here is the final question I want you to sit with. The Chicxulub impact was random, chaotic, 30 seconds in either direction, and none of us are here. Does that make human existence feel more precious to you, or more fragile? There is no right answer, but there might be a dark chapter. 1. Leave it in the comments, and if you found this video valuable, share it with one person who needs to have their mind stretched today. We'll see you in the next chapter.